We're going to take a look at the PARCC practice problems in Unit 2, and we're going to start with problem number 6, and we're going to go through problem number 10. So here we go. Oh, and these problems were posted on the 2017 practice tests. A pool cleaning service drained a full pool. The table shows the number of hours it drained and the amount of water remaining in the pool at that time. Part A. Plot the points that show the relationship between the number of hours elapsed and the number of gallons of water left in the pool. Select a place on the grid to plot each point. All right. Now, notice how it said just to plot the actual points. It has not asked us to plot anything beyond that. So, the first thing I'm going to do, just to make my life a little bit simpler, is I'm going to take a quick little picture of the, or maybe not, I guess I won't be allowed to. It would be nice to take a picture of this, but it won't let me. So I'm going to write down the table closer to the graph so that I don't have to keep scrolling up and down. So we have 3, 13,200. We have 5, 12,000. We have 7, 10,800. I have 9, 9,600. And finally 8, 11, 8,400. And so I'm going to scroll down and let's plot these points. So 3, when x is 3, it's right here because it says time in hours, so we have 3 here. And I go up to 13,200, so we go all the way up. So 13,200 is going to be somewhere in here. And it will only let me do halves and full points, so we know it has to be there. Excuse me. 5, 12,000, so we have 5, 12,000, so 5 we go up and 12,000 is already labeled. Makes life really easy when it's an exact point. 7, 10,800, so 7,000 and 10,800. 9, 9,600, so we have 9, 9,600, which is an exact point. And finally 11, 8,400, should be right here. And I can see clearly that these dots will give me a line. This is a linear relationship, which should help later on. All right, let's keep going. Part B. The data suggests a linear relationship between the number of hours the pool had been draining and the number of gallons of water remaining in the pool. Assuming the relationship is linear, what does the rate of change represent in the context of this relationship? When it says rate of change, what it's really talking about here, this is slope. And so it wants an explanation of what does the slope mean in the context of this problem. So if I were to scroll up, and the slope will stay there, it's asking, what does this ratio of rise to run mean for pool draining? Well, obviously this is the amount of water and it's decreasing. So this is the amount of water decreasing over time. And we're going to need that little thing in a little bit, I'm willing to bet, so I'm just going to keep it. So, here we go. Option A. The number of gallons of water in the pool after 1 hour. Well, no, because this is how much is draining per hour. The number of hours it took to drain 1 gallon. No. The number of gallons drained each hour. Yes, that is what we're looking for. Question C. What does the y-intercept of the function represent in the context of this relationship? Well, if I go back to my graph, the y-intercept is going to be way up here, right? And that's going to be how much water is remaining after 0 hours of draining. Well, therefore, that means that's how much water was in the pool to begin with. So, A says the number of gallons of water in the pool after 1 hour. No. The number of hours it took to drain 1 gallon. No. Number of gallons drained each hour. No. Number of gallons of water in the pool when it is full. Yes, because at 0 hours, the pool is full. Question D. Which equation describes the relationship between the time elapsed and the number of gallons of water remaining? So, let's scroll up here. And that's why we kept our little slope triangle. So, over this time here, the rise is going to be negative because we're losing, it's going down, we're losing water in this case. And so I went from 10,800, 10,800, I write that, to 9,600. So over that time, how much water was lost? Well, when I subtract these two, I get 1,200. So our rise is negative 1,200. And our run is 2, because it took 2 hours. And you know that slope, or the rate of change, is equal to rise divided by run, which is going to be equal to 1,200 over 2, which is, negative 1,200 over 2, which is equal to negative 600. So I know my slope, my m value, is negative 600. And I know that since this is linear, we have y equals mx plus b, where m is slope, b is y-intercept. So right now I know I have y equals negative 600 x plus something. Well, what is that something? There are a couple of ways I could do this. One is I could use my graph. So now that we've used this, I can erase it. And let's use the tools available to us. That might be fun. I have a ruler. So I'm going to place the ruler on, so this ruler likes to rotate about the middle. So I'm going to place the middle of the ruler on one of the points, and I'm going to rotate it so that it is, there we go. And so if I get a line here, it's getting really close to 15,200 gallons. So then let's go ahead and scroll down and look at our options here for a y-intercept. Well, clearly, the 13,000 doesn't make sense. And our slope is negative 600, so therefore, my equation has to be A. Alright. Now, the other way I could have done this is I could have taken some of my points. And this is probably a safer way. I could have taken, say, 3, 13,200 and said 13,200, and I plug that in for y, is equal to negative 600 times 3, and that's my x value, plus b. So 3 times negative 600 is negative 1,800, plus b equals 13,200. What's the opposite of negative 1,800? Positive 1,800. And I get 15,000 is equal to b. So that is the algebraic means of solving that problem. And there we have it. Brilliant. So, oh, come on. There we go. And so I've answered all of my questions. So let's go on to the next problem. All right, the figures show a right circular cylinder, I teach math, and a right circular cone. So let's talk about this vocabulary. What does the right mean? This right is saying that there is a right angle between the base and the height, just like here, as opposed to, say, a non-right cylinder. All right. The cylinder and the cone have the same base and the same height. What is the volume in cubic feet of the cone? Well, if I didn't remember the equations, here are my options. I can hit the exhibits and I can scroll down and look. It says the cylinder has a volume of pi r squared times the height, whereas the cone has a volume of 1/3 pi r squared times the height. So that was awfully helpful. Let's write those equations down. So for the cone, we have 1/3 pi r squared h. For this one, we just have volume is equal to pi r squared h. Okay, so then, what is the volume of the cone? So we're talking about the cone. And so we have 1/3 pi times the radius, which is 4 squared, times the height, which is 3. Well, right away I know 3 divided by 3, that's going to cancel each other out. That's going to be 1. So I have 4 squared, which is 16 times pi. And it wants me to give the answer in terms of pi, which means I don't have to multiply the constant of 16 by pi. What is the ratio of the cone's volume to the cylinder's volume? Enter your answer in the box and enter only your fraction. Well, the ratio, when I say ratio, you think fraction. Oh. When I say ratio, you think fraction. So right away we can tell that the cone's volume is going to be 1/3 the volume of the cylinder, because the cylinder and the cone both share the same equation, except that the volume of the cone is multiplying 1/3 times the volume of a cylinder of the same radius and the same height. So we need to type in 1/3 into our text box, which I will right now. So I'll hit 1, and then I need a fraction, 3. And to get out of the fraction, you need to use your arrow keys. And so there we go. And so, since it says enter only your fraction, that's what I've done. All right, moving on. Ah, this looks like a fun one. Martin is considering the expression 1/2 times the quantity 7x plus 48 and negative, or so essentially this is the way I would prefer to think about it, -1 times the quantity 1/2 x minus 3 plus 4 times the quantity x plus 5. He wants to know if one expression is greater than the other for all values of x. So essentially we have one expression here and one expression here, and he wants to know if one of those two expressions will be bigger no matter what value of x you pick. And odds are the answer is going to be no, because when you multiply by a negative, it changes the sign. So, and like obviously 2 is bigger than 3, but sorry, 3 is bigger than 2, my fault, but negative 2 is bigger than 3. So probably not. So here we go, part A. Which statement about the relationship between the expression is true? A. The value of the expression 1/2 times the quantity 7x plus 48 is always equal to the value of that. Well, that is a possibility. I think what we're going to have to do here is simply simplify these to its lowest term. So what is 1/2 times 7x? Well, 1/2 times 7x is 7 over 2x. 1/2 times 48 is going to be plus 24. For our other equation, we have negative 1 times 1/2 x, which is going to be equal to negative 1/2 x. Negative 1 times negative 3 is positive 3. 4 times x is positive 4x. 4 times 5 is 20. And let's combine the terms. So 4x minus 1/2 x is going to be 3.5x. But wait a second, 3.5 is the same as 7 over 2x. Okay. So then it says 3, positive 3 plus 20 is going to be plus 23. Very close, but not the same. All right, so we can cross out A. Let's go ahead and do that. Ka-chow. That's the most fun part of this thing, Xing answers out. All right, the value of the expression 1/2, okay, the red expression is always less than the value of the expression. Well, in this case, it is clearly bigger because if x was 0, this would have 24, this would have 23, so no. The value of the expression is always, the first expression is always greater than the second. Now, be careful here, because you'd be tempted to say yes, because 24 is always bigger than 23. But wait a second. Let's put in a negative number. Let's say we have negative 1 here. So we have negative 1 times 7 over 2, which would be negative 3.5 x. Oh, sorry, because we said x was 1, negative 1, plus 24. Then over here, we would end up with negative 3.5 plus 23. So over here, we would get 19.5. Over here, we get 20.5. So in this case, yes, even with the negative number, we end up with a value that is larger. Oh. So I want to get off of that. There we go. Part B. Show or explain how you found your answer in Part A. Enter your work or your explanation in the space provided. All right. So, it would be expected for you to do exactly what I have done, but only in written form. And I realize it's probably pretty boring to listen to me do it. So, after I've already explained it. So I'm going to skip that. But you definitely need to show all of this work here, as well as all of the work here. Question C. Write a new expression that always has a greater value than both these expressions. Well, in this problem, we had plus 24. And because of that positive 24, and it wasn't being multiplied by anything, we always ended up a little bit bigger because we had the same slope here. It's as if you have two parallel lines, right? Here's one line, here's our red line. So they'll never end up touching, and they'll never end up having one bigger than the other. Well, if I have a third parallel line that I want to have even greater than the other two, it would have to have a y-intercept that's even larger. So I could pick any number I wanted as long as it was larger than 24. So how about 25? So the expression I would go for here would be, well, we have to have a same slope because we're dealing with parallel lines here. So we would have, and I don't think it's going to let us do an equal sign. Let's see. I'd go with y equals, and then I want a fraction, 7, using the down arrow, halves, the side arrow, x, plus 25. And there we go. Notice how this ends up just being a linear equation. Alright, I'm going to stop the video here and do the last two problems on a separate video.